Leaving port, a boat sails 10 kilometers on a bearing of 130 degrees and then 15 kilometers on a bearing of 10 degrees. Find the distance and bearing of the boat from the starting point at port. Make sure your diagram has values for lengths and angles. So when solving a problem like this, we just go step by step and try and write down or diagram the information. So it says leaving port, a boat sails 10 kilometers on a bearing of 130 degrees. So when drawing a bearing, you always start with a cross, which shows the north, south, east, west directions. And then it says, let this first point be called, say, P. So the boat sails 130 degrees, from P, which simply means you go from the north direction clockwise and you count about 130 degrees, let's say up to here. So if that's 130 degrees, then we draw a line from this point, and let's say this is what we can call 10 kilometers. After that, the boat turns and goes on a bearing of 10 degrees, 15 kilometers. So once again, at this point here, let's draw a cross to show the north-south directions, and then 10 degrees. So 10 degrees would be about, and again from the north, a very small angle, let's say that much, and that's 10 degrees. And the boat goes from here a distance of 15 kilometers. So we'll draw a line that's slightly bigger than the first line. And remember, this doesn't have to be to scale, it just has to be approximately correct. So we have two lines. Now, this first one, as we saw, was 10 kilometers, and the second one was 15 kilometers. 15 kilometers. So the question then says find the distance and bearing of the boat from the starting point at port. So this is important. You're trying to find the distance and bearing from the starting point. So let's just complete the diagram anyway. Let's complete the figure up to here. Okay. It helps sometimes to draw the cross at this point as well. So let's just go ahead and do that. Okay. It's easier to see the angles. Let's call let's call this side, say this is D, and this could be called, say, anything, say C. So you have a triangle, non-right angled, PDC. So this corresponding sides are lowercase p, lowercase d, and lowercase c. Now you are asked to find the lowercase d. Let's see if you can get an idea about some angles here. So, for example, what would be at the angle at this place? That shouldn't be too difficult because if the whole angle is 130 and one part of it is 90, then this side is 130 minus 90, which is equal to 40. So if that is 40, then you know by alternate interior angles that this one at the bottom is also 40. If that's 40 and the total angle here is 90, then this angle here is 50. So you see, by doing this, we've been able to find one of the angles, which is 50 plus 10, or 60 degrees. Now that really helps because you have one angle, you have two sides that are, yeah, that are on either side, and you can find D from that. So let's go ahead and try and find D, which is the side that we want to find. Let's use the cos rule. So we have D squared is equal to C squared plus P squared minus 2CP cos D. And so plugging in the values, that's 10 squared plus 15 squared minus 2 into 10 into 15 cos 60 degrees. Simplifying this, you get d is 13.2 kilometers. And of course, don't forget to take the square root to find d, which is what I've already done. The next step is to find the bearing angle, and that's from port to the starting to the ending point. So what angle are we talking about here? You should be very careful in this case. The angle you're talking about is this angle, right? Up to this point. So how do you find that? Now, you can find that angle if you know the other angles, correct? So you do know that this little angle is 40, and then the total angle over there is 90. So let's try and find the remaining angle. So let's say this one. Let's try to find this angle in the triangle. That's angle P. So let's try to find angle P. You can use the sine rule. So you can take sine P divided by P is equal to, say, sine D by D. Okay. And so sine P divided by P, which is the opposite side 15, is equal to sine D, which is sine 60, over D with 13.2 that we already found. So from this, you can get the value of P, and P will be equal to the sine inverse of 15 sine 60 divided by 13.22, which is 79.1 degrees. Right? Just use a calculator for it directly. So if this angle is 79.1 degrees, then the bearing that we're looking at is simply 130 minus 79.1, which is 50.9. And that's the answer that we're looking for. Okay, so we can write that down. The bearing is equal to 50.9 degrees.